Yes, class. Am I audible to all of you now? Jeffreen, Shama, Zainab, is it audible?
Yes, ma'am.
Yes, ma'am.
Okay, so in the last class, we stopped exactly at this point where we were calculating this displacement from the mean position, the forces, or basically spring mass system we were analyzing. So what exactly was the spring mass system? In our spring mass system, we have a spring where the free end is attached to the mass, and that mass block spring is called as the spring mass system. Now, what you all have to remember? Three things. Firstly, that the force is directly proportional to the displacement from the mean position. That is, F is directly proportional to X. Second point, you have to remember that restoring force is directed towards the mean position. Third point, we have discussed that the energy which is produced in a spring, it is half kx square. So all these portions we have discussed. Now we have to discuss the conservation of energy. Now this is the easiest part. See, you have been hearing this statement, energy can neither be created nor be destroyed, neither be created nor be destroyed, right? So what is meant by this? See, if I have 5 points in my, or let's take one example. Let's say I have 3 points in my hand. All right, here I have some 3 points, something it is. All right, and in this, and all right, so 3 points, I'm having this in one of my hands. Let's say I'm just having 2 points in this, or let's make it 4. Let's make it. All right. Now, if I give 1 point from this forehand to this, still it is 4 and 3. The ratio is the same. What has happened? 1 point has transferred from one of the fingers to another, right? So total number is still constant. So when the total number is still constant, we say it's the conservation. So similarly, if some amount of energy is being transferred from one system to another system, we'll say it's the conservation of energy. So your energy cannot be created somewhere. Your energy does not get destroyed. It just transfers in from one form to another. Like your kinetic can transfer to potential. Potential can transfer to kinetic. So this is the system how it goes about. So non-conservative forces should not be present in your system. Why? Like frictional forces. These are dissipative forces. They can get transferred in the form of heat. So we are not talking about non-conservative forces because they'll be dissipated. We are only talking about conservative forces. So in our cases, we have talked about only two kinds of energies. Yes, kinetic energy and potential energy. So sum of the kinetic energy and potential energy, this is going to be 0. So kinetic energy plus potential energy, this is going to be 0. That is what is meant by it. Means kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Or you can say from, if you transfer this here and transfer this here, you can say kinetic energy final minus kinetic energy final minus kinetic energy initial is equal to potential energy final minus potential energy initial. Or in fact, you can leave this statement also because this is not necessary. If you get the opposite signs, it might not work. Basically, you can say change in kinetic energy plus change in potential energy is equal to what? Constant. It's constant. Or you can say it is equal. It is equal to 0. So both of it can be equated. So if change in kinetic energy is equal to change in potential energy, we say energy is conserved. All right, we say energy is conserved. So see, what is the proof regarding it? Delta KE is equal to the work done, right? What is our work done? This is a very small proof that we can talk, or when we are going about this. See, whenever you're talking about this proof is not a derivation. This is just a method to understand that yes, our energy is going to be conserved. See, what is the change in kinetic energy? This is equal to half mv square, right? What is work done? We have studied that change in work done is force into displacement, right? Force into displacement. This is the work done. Now force is mg into dx. This is the work done. Basically, you can say work done is equal to change in potential energy. And according to work energy theorem, we know change in kinetic energy is also equal to change in work done. So change in kinetic energy is equal to change in potential energy. From this, you can conclude this. Or if you wish, you can add that step 2 is equal to constant, or it's better if you write 0. It's better if you write 0 so that they both can be equated. All right. Write it till here, then I'll discuss. This part only is enough or some other part you're referring to?
This part, ma'am.
Okay, completed. Now see this next question. This is an important question. So what we are going to do, we have to show that, see, if freely falling body, what do you understand by the term free fall? Can anyone explain what is meant by the term free fall? Anyone? Free fall, we have done this. So you must be knowing free fall.
There are no forces against the falling object.
Yes, basically gravity is assisted. Gravity assisted movement, that is free fall. So gravity, like motion under gravity, there we had free fall. And yes, definitely, Simon, no other forces are stopping the motion. No other forces are acting as a barrier. All right, so definitely correct, Simon. Now, there is this question where you have to prove, and basically this is a part of this only what we have studied. So we take a point A here at the starting. Now at A, just a second. So at A point, now at A point, if you're talking about the potential energy, since it is at a height and gravity is assisting, so gravity, we have talked about gravity, that whenever you're talking about gravity, so you will use the free fall case. Okay. Now, before that, before we are talking about the free fall case, see, potential energy will be acting. And yesterday only we have studied that potential energy is mgh. So here potential energy becomes mgh, very easy derivation. But what will be the kinetic energy? Can anyone tell what should be the kinetic energy here when the ball from the starting point is taken or it is thrown? But at this is the topmost point. Can anyone answer what should be the kinetic energy with a valid reason? No guesses. Yes, any valid answer? Kinetic energy. Half mv square, p square by 2m. What should be the kinetic energy? Yes,
Zero.
correct. Zero. Reason?
Because it's not in motion.
No. See, Shaima, that answer is correct. Definitely kinetic energy is zero. So your answer is right. Very good. But the reason exactly is not correct. Precisely the reason is that at the highest point, if you remember when we were discussing motion under gravity, so at the highest point, the velocity becomes zero. And we are talking about point A, which is the highest point. So yeah, velocity is zero in two cases. One, partly your answer was right. If the initial velocity is not present, then definitely the kinetic energy will be zero. But the second case that we have, which is the actual case, is that this is our highest point. And at the highest point, we have the velocity zero. Velocity zero hogi. So what we'll have? Kinetic energy zero. So this is the reason. So okay, good. This is the case. So what is the total energy? We have the total energy as E means the total energy is equal to 0 plus mgh, which is equal to mgh. Now we are talking a point which is B point. Now B point is taken from the lowermost portion. Just a second, let me show you the figure first. Huh. So yes, it is taken from this bottom part. This is the part. Now see, when we are talking about this portion here, force is what? Potential energy is what? Zero. Now, why is the potential energy zero here at B point? We have discussed this yesterday. Reference line, zero of potential energy, no displacement. Yes. So this will straight away be mg into 0 is 0. Now, when we are talking about kinetic energy at this B point, it is half mvb squared, not the velocity at the highest point. So as to differentiate it from that highest point, I'm taking the velocity from the lowermost point. So that is vb, correct? Now, what is this value of this vb? We'll be using our uniformly accelerated motion equations. The third one, because we do not have time, we have no information about time. First equation has time, v is equal to u plus 8t. Second equation has time, s is equal to ut plus half 8t square. Yes. Now the third equation is the equation which has no time. So v square minus u square is equal to 2as. V is what? V is VB. What is U? Initial velocity is 0. 2 is a constant. Acceleration is acceleration due to gravity because it is free fall. And S is the displacement or height. So if we substitute, what do we get? This will be kinetic energy at B point will be half M. V square is 2gh. So 2gh, 2 cancelled. So this is equal to mgh. Now again you are calculating the total energy EB. This is equal to mgh only. This shows that energy at both the points are the same. Energy is the same. It remains the same. Write it down. No, no, not about force. See, forces are there. Gravitational force is there, na? So you cannot neglect it. Reason is that velocity at highest point is zero. That's the only reason. Okay, class. Now work done is completed, energy is completed. So work, energy, and power. Last topic is power, but class one topic you have additional to this. Power we'll be doing. It's a very short topic. It will be completed, I hope, in this class only. It's not very lengthy because you just have the basics of power. Moreover, you have collision in your syllabus that you have to focus on because you have all the types of collision included. Elastic collision is there, inelastic collision is there. So we have to focus on that too. So collision is a little lengthy topic and it comes in the exam. So we'll be discussing that too. So that portion will be left then. It is power, it is over. So what is power? Work that we have studied. Work done is whatever force is being applied to cover a certain displacement, right? A certain work amount of work which is done to cover the certain displacement, right? So it is the rate of doing work. Basically, work done per unit time. Rate, whenever the term rate comes, I've told you several times that this term rate means something which is changing with respect to time. At 0, you have 1 watt. At 3 seconds, you have 2 watt. Let's say at 5 seconds, you have 10 watt. So 1 by 0, 2 by 3, 10 by 5. These are what rate of doing work. And that is exactly known as power. How much work you are able. Human also have power, right? Humans also have power because they also do some work. Their muscular activity also does some work. So power, we say no, you are more powerful. A person is more powerful. Right. So why, how can we say that? If a person lifts heavy weight, we say it's powerful. Why? Because there is a displacement which is there. See, in physics, if you have held a very, very heavy, let's say even 60 to 70 kg block in your hand and you have not moved at all. There is not a single displacement covered. So in literature, you have done a lot of work. You are tired. But in physics, you have done nothing. That's zero work. That's absolutely zero. All right. So it is the rate of doing work. All right. So power is, just a second. Okay, so power is what? It is the rate of doing work. So work done per unit time. This is called as the power. Scalar quantity. This chapter is easy to deal with because everything is scalar. Work done is scalar. Energies are scalar. Power is scalar. So this is an easy part. Now, when we are talking about SI unit, see, work done's unit is joules, time is seconds. So 1 joule per second has a very good name, which is 1 watt, represented by capital W. Okay, so this is the introduction of work done. Now, average power, instantaneous power. Now, by this time, you all should be very clear when to use instantaneous power, when to use average power by yourselves without even me telling. Because average, we have always discussed whenever you are having a duration. You are having a duration, and that time you take change in power. So, not power exactly, change in the work done by the time duration. How do you calculate change? This delta symbol, what does it symbolize? Delta means you are calculating the change, which is final minus initial. But when we are putting this symbol D, what is this symbolize? This is showing differentiation. So your algebra is used here. DWD means change in work done by change in time. And when you are calculating instantaneous, means you are calculating it for an instant, time instant, for a quick time instant you are calculating. So that is DWD means differentiation of work done over. This has to be done very well, properly. This should be understood. I'll tell this later. First, copy down this part. talking about the this formula of power. So see, power is equal to work done divided by time. Just that. So whenever we are talking about power is equal to work done by time. Right. So work done was force into displacement. So now in this new formula of power which you've studied, power is equal to dW over dt. So if you substitute, okay, just wait, let me check the internet. Now check, just tell me if it is better. Now see power, when you substitute this, df dot ds over dt. Now see, if force is constant, if F is equal to constant. So what we'll do, we are going to take out the force out. That's the rule. So if you take force out, you are left with ds over dt. Now what is this ds over dt? This is nothing but formula of velocity. So power is equal to force dot velocity. This is the new formula. So we'll discuss this question. See, this is a very short question. So let me discuss this first. So a force of 10 Newton acts on a body and it starts moving with a velocity 5 meter per second. Calculate the power. So power is equal to force into velocity, which is equal to 50 watt. Next question, we'll discuss it together. First, write down this. See class, this sine 1 in 5 which is given, this is basically sine theta, that is 1 by 5. So sine theta here is equal to 1 by 5. Like you have normal angles 30 degree, 40 degree, 45 degree, 90 degree, 60 degree. So you have a definite value of them. 1 by root 2 we write. Sine 45 is what? We write 1 by root 2. What is sine 30 degree? We write half. So that half 1 by root 2, that is given in terms of the actual answer. Like sine theta here is equal to 1 by 5. So solve it in that manner. Okay, Zainab has answered also. Very good. Other students, I want your answer. Okay, Zainab, we'll see. So if you have not solved it with this sine theta, please recheck it. I'll be discussing it right now. So you have to make the FBD, that is the free body diagram, in that inclined plane. Remember, this is the case of an inclined plane. So use it. So I'll show you this sine theta, sine 1 by 5, and see all the forces which are acting you have to use, because ultimately power is equal to force into velocity, right? So please try this. In terms of PE, as in potential energy, you're saying?
Yes, ma'am.
Okay, you can, but in potential energy, you will be having the angle also here. Mass is given. The issue that you will be facing here is the angle theta, which is mentioned. And theta is not mentioned directly. It's given as sine theta, not even sine theta. Sine is 1 in 5. 1 is basically the perpendicular and 5 is the hypotenuse. So even if it wasn't given to be cos theta, mg sine theta, yeah, okay, okay. If you take that, that's fine. That's fine then, Zainab. If you take theta, if you involve theta, then your answer is fine. Others also using this answer. Okay, so Zainab has changed her answer. Let me discuss the solution. Now, see, if there's a body of mass 100 kg, so let's say this is M. Let's not put the values right now. See, let us discuss this only first. So this is mg. This is theta. So this becomes mg cos theta. This becomes mg sine theta. This is mg sine theta. Okay, so a body of mass 100 kg is moving up an inclined plane with a velocity I need 10 meter per second. Slope in is 1 and 5. So 1 means the perpendicular, 5 means the hypotenuse. Now see class, if one thing apart from this question, it's not necessary that you will get the exact value on the same values of sine theta. Just in case if you get a question where you require cos theta or you require tan theta and only sine theta is provided, in that case, what will you do? U square plus b square. Calculate whatever you want to calculate and then get your angles theta. All right. So this is equal to normal reaction. Now this is providing the velocity. We have our to be so mass 100 G. So 2000 watt, 2 kilowatts. This is the answer. Yes, then that is correct. That is accurate, in fact. 1960, correct. See, this is the first body of mass m1. It has initial velocity u1. This is mass m2 with initial velocity u2. So there is no collision which has occurred. During collision, all the forces cancel each other and the net force we get is zero. So this is during collision. And what happens after collision? A new final velocity is achieved, v1 and v2. So this is the case after collision. So what exactly is this process of collision? Collision is basically an isolated event in which, see, collision is an isolated event in which large force acts on the body for a short duration of time, means impulsive forces, which results in the changes in their velocity. So isolated event means net force is zero during that event, right? I've already told you what is an isolated system, where large forces act for a very short time, right? Collision is very short, quick forces. They just come in contact, bombarding occurs, and then they leave each other. And physical contact is not necessary. That we'll study later. Write down this introductory part first.